Welcome to Python Operators. Today we'll learn about operators, arithmetic operators, relational, assignment, logical, membership, identity, and bitwise operators. An operator is a symbol. It takes one or more operands or values and performs an operation on them to obtain a result. Consider basic math. 2 plus 3 is 5. Here, plus is the addition operator. It adds two values, 2 and 3. 2 greater than 3. This checks whether 2 is greater than 3 and accordingly returns false. Let's begin with basic arithmetic operators. These are basic mathematical operations. These are addition, subtraction, multiplication, division, exponentiation, floor division, and modulus. You're familiar with some of these. The addition operator is a plus sign and adds the two values around the operator. 3 plus 4 is 7. Subtraction has a minus sign and subtracts the second value from the first. 3 minus 4 is minus 1. The operator for multiplication is an asterisk and multiplies the two values. 3 multiplied by 4 is 12. The division operator, which is a forward slash, divides the first value by the second. 3 by 4 is 0.75. Two asterisks denote exponentiation and raise value 1 to the power of value 2. 3 to the power 4 is 81. The operator for floor division is two forward slashes. It divides and returns the integer part of the quotient. 10 floor divides 3. 10 by 3 is around 3.33333, so this gives us 3. Finally, the operator for modulus is the percentage sign. It divides and returns the remainder. 10 mod 3 and 10.5 mod 3. 3 perfectly divides 9 and the remainder is 1. 3 perfectly divides 9 and the remainder is 1.5. Arithmetic operators are binary operators in that they operate on two values. Other binary operators are relational operators. These let us compare values. We have 6 of these. Less than, greater than, less than or equal to, greater than or equal to, and not equal to. The less than operator returns true if the first value is less than the second. Is 3 less than 4? Yes, it is. The greater than is the opposite of that. Is 3 greater than 4? No. This one checks whether the first value is less than or equal to the second. Is 3 less than or equal to 4? Yes, it is smaller. The greater than or equal to is the opposite of that. Is 0 greater than or equal to 0? Yes, they are equal. Equal to has two equal signs and checks whether two values are equal. Is 0.5 equal to true? That is untrue. True has an integer value of 1. Not equal to is the opposite of this. Are minus 1 and minus 1.0 unequal? No, they are equal. Now if two equal signs check for equality, a single equal sign performs assignment. But we can do more than that. Some operators can perform operations and then assign the result to something. We can add, subtract, divide, multiply, modulus, exponent, or floor divide, and then assign the result to the same variable or another. Let's take examples. Assign simply assigns the value of the expression on the right to the variable on the left. A is 7. A is now 7. Add and assign adds the value of the expression on the right to the value of the variable on the left It then assigns this to the variable on the left. A add and assign 2. A was 7. Now it's 9. Subtract and assign subtracts value 2 from value 1 and assigns the result to the variable on the left. A subtract and assign 2. It is now 7 again. Divide and assign divides value 1 by value 2 and assigns the result to the variable on the left. A divide and assign 7. 7 by 7 is 1.0, so A is now 1.0. Multiply and assign multiplies the two values and assigns it to the variable on the left. A multiply and assign 8. 1.0 multiplied by 8 means A now holds 8.0. Modulus and assign performs modulus on the values and assigns the result to the variable on the left. A mod and assign 3. 8.0 mod 3 is 2.0, which is what A now holds. Exponent and assign raises value 1 to the power of value 2 and assigns the result to the variable on the left. A exponent and assign 5. 2.0 raised to the power 5 is 32.0. A is now 32.0. Finally, floor divide and assign. Floor divides value 1 by value 2 and assigns the result to the variable on the left. A floor divide and assign 3. 32.0 floor divided by 3 is 10.0. A is now 10.0. You are aware of conditional statements. Logical operators let us combine such conditions. We have three logical operators in Python: AND, OR, and NOT. AND returns true only if both conditions are true. Otherwise, it returns false. 7 is not greater than 7 and 2 is greater than -1. But that isn't evaluated since the first condition is already false. This is short-circuiting. This expression returns false. OR is a bit looser. It returns true even if one of the conditions is true. It returns false only if both conditions are false. The same expression returns true here because although 7 is not greater than 7, 2 is greater than -1. NOT simply inverts an expression's Boolean value. 0 has a Boolean value of false, so NOT of this gives us true. Membership operators tell us whether a value is a member in a certain sequence. These are in and not in. In returns true if the value is part of the sequence. Consider this list. Is the string fox a part of it? No, it isn't. Is the string me a part of the string disappointment? Yes, it is. Not in is the opposite of in. It returns true if the value does not belong to the given sequence. Is the string pot not a part of the string disappointment? Yes, it isn't. Identity operators let us check whether two objects aren't just equal but also identical. It checks whether they're the same. These are is and is not. Is returns true if two objects are the same. 2 is 20. That is untrue. How about these two strings? True, they are the same. Is not is the opposite of is. It returns true if the two objects are different. 2 is not the same as 2. True, because one is an integer and the other is a string. This one, A and B are two lists with the same values but different IDs. So A is not B. Finally, bitwise operators are the ones that operate bit by bit. We have 6 of these: binary AND, binary OR, binary XOR, binary ones complement, binary left shift, and binary right shift. Binary ANDs values bit by bit. 3 and 4. The binary for 3 is 0, 1, 1, and that for 4 is 1, 0, 0. And in each bit we get 0, 0, 0, which is the binary for 0. We'll discuss bitwise operators at length later in the course. Binary ORs values bit by bit. 2 or 3. The binary for 2 is 1, 0, and that for 3 is 1, 1. So this gives us 1, 1, which is binary for 3. Binary XOR performs exclusive OR bit by bit. 2 XOR 3, this gives us 1. Binary ones complement returns the ones complement of the values binary. Ones complement of -3 is 2. Binary left shift and right shift operators shift value 1 left or right by an amount of value 2 places. 2 left shift 2 shifts 1, 0 to the left by 2 places. This gives us 1, 0, 0, which is binary for 8. 3 right shift 1 shifts 1, 1 to the right by 1 place. This gives us 1, which is the binary for 1. Don't worry if some of it felt overwhelming. This is only a brief introduction of operators, and we'll get into details later. Until next time.